All right, let's get started, folks. We're going to talk about parametric equations today. So far, what we've talked about, I'll call normal equations, or the other way we describe it is rectangular equations. We have y equals some function of x. So we plug in x and we get y. So that's the kind of functions that we've been using so far. We plug in some number and we get another number. For parametric equations, what we're going to talk about today, we have, thank you. For parametric equations, I think it says 130. It says we have x equals some function of t, and y equals some other function of t. T is the parameter. So we could think of the parameter as time. So we plug in a t, and we get x and y. So we can think of x being some function of time and y being some function of time. So if you're in physics or you've taken physics, if you talk about projectile motion, those are parametric equations. You plug in a time and you get an x coordinate, and you get a y coordinate that describes the path of an object flying through the air. So we call these parametric equations. T is the parameter. Time is a common parameter. It's not the only parameter that we use. All the points, f of t, comma g of t, so these are my x and my y, together are called a plane curve. So that's just the fancy name we give for a graph if we're talking about parametric equations. We say we're going to graph the plane curve. So projectile motion is an example of parametric equations. We will talk about another special example of parametric equations next time when we talk about polar coordinates. So x and y are going to be a function of r and theta. So an angle and a radius. That's a special kind of parametric equations. All right, so the first thing we want to do is talk about how we graph these things. Well, the most basic way to make any kind of graph is to plot or make a table of values. So let's say we want to graph my set of parametric equations, x equals 2t and y equals t squared plus 1 on the interval -2 to 5. Oops. And just a reminder, this means -2 less than or equal to t less than or equal to 5. So I'm going to make a table of values, t, x, and y, and plot points. So here's going to be my graph. And we're going to start at -2. When t is -2, we plug that in here for x, and we get a -4. And when t is -2, we plug that in there, and we get a 5. So my point is -4, 5. So I get a point roughly there. I'm going to plug in -1. When I plug in -1, x is -2, and y is 2. When t is 0, x is 0, and y is 1. So I get the point 0, 1. Now, before I go on, what are we going to guess this curve is going to look like? Parabola, right? Because here we have x, and here's something that has something to do with x squared. So it's kind of like y equals x squared. All right, so let's keep going. When t is 1, we plug this in, we get the point 2, and we get 2. So there's our point there. T is 2, we get 4 and 5. And I'm just going to jump ahead here so that we could keep going. So I need to go all the way to 5. When t is 5, x is 10, and y is 26. So we get a point here. So my graph is going to look like this. And as t increases, we move from left to right. We call that the orientation of the curve. Left to right. This is what we call the orientation. So we could say left to right, or we can draw the little arrows. And that's one interesting thing about parametric equations, is that sometimes the orientation is the opposite direction. For regular equations, x is always we always move from left to right because we go from x getting smaller to x getting bigger. But for parametric equations, sometimes we go the opposite direction. So we'd say this graph has left to right orientation. We could possibly parameterize this curve in a different way that would give us the same curve but with the opposite orientation. So we travel the opposite direction. All right, questions? All right, our calculator will also graph parametric equations. So let's look at that. All right, so in our calculators, if you go to your, folks, let's stop talking, please. If you go to your mode, so right now, this fourth one, your calculator is going to say function. That tells us we're in function mode. Our calculator can graph in parametric mode, in polar mode, and in sequential mode. So we're going to go over to parametric mode, hit enter, and quit out of there. We'll talk about polar mode next time. And now if you go into your y equals, folks, if you go into your y equals, you get, instead of a y1, y2, you get an x1 of t and a y1 of t. So you get a pair of equations. So let's graph, in this example, x equals t squared and y equals t minus 1 on -3 to 3. So before we graph this, what are you going to guess this thing is?
Regular line. No, parabola.
A parabola, but this time the x part is the squared part. It's going to be a horizontal parabola. So let's take a look. So I'm going to go in here, and x is 2t. Whoops, that was the last one. X was t squared. T squared. And y, so when you press your x t theta button, you get a t instead of an x. And y is t minus 1. And I'm going to go into my window, and I'm going to put this at -3. T minimum at -3. T maximum at 3. And then I'm going to graph this. And notice as it graphed, it did this part and then that part.
So that's the pressure.
My window, if you do zoom standard, just do zoom 6.
Mine's not working.
So my graph turns out like this. And when the curve graphs on the screen, it goes in this direction. I would, all right, folks, I would call this clockwise orientation. Because it's not right to left, and it's not left to right. I would call it clockwise.
Why did I get that?
I don't know. Is this what you put in? Is this your window?
Why is it 0.53?
That's just how much it goes between each t value. That doesn't really matter. I'm just set my window from -5 to 5.
Yeah, 1 second. I still only got 1 line. Yeah, I'm only getting like 1 line. Yeah.
Are you sure you're going from -3 to 3? Are you first sure this first one's negative?
I got it.
All right, let's look at another one. This one we're going to say x equals t cubed and y equals t squared. So this one, a little different. Let's take a look at what that one looks like. I'm going to go into my y equals, clear, t cubed, and y equals t squared. And notice it graphed this side first and that side second. So you can graph lots of interesting kinds of curves with parametric equations. So this one turns out to look something like this. And we have left to right orientation. All right, questions on you graphing these in your calculator?
Pretty simple.
Now, be aware that when you start writing your program for your conics project, it's going to do some things to your window, and it's going to turn the axes off and that kind of thing. So you're going to have to change those back if you want to see your graph normally. Every time the program runs, it turns the axes off and sets the window in a different way. All right. Sometimes we are going to want to, from a set of parametric equations, write the normal rectangular equation. And to do that, we eliminate the parameter. And the basic idea here is we solve one equation for t and then substitute into the other equation. So for example, if we had x equals 1 over the square root of t and y equals 2t squared, and we want to eliminate the parameter to get y equals f of x. Well, a couple of things we need to be careful of here. What values of t are we allowed to use in this set of equations? We have to have a positive t. So t has to be greater than, can t equal 0? No, because we divide by 0. So t has to be greater than 0. Well, if t is positive, what does that mean about x? X is also positive. So x is going to be greater than 0. So we have a domain restriction here. X has to be positive. I'm going to solve this for t. So I'm going to take the reciprocal. 1 over x equals the square root of t. So t equals 1 over x squared. I'm going to plug that in here. Y equals 2 times 1 over x squared squared. Y equals 2 times t squared. So we get 2 over x to the 4th. And x is greater than 0. Well, let's take a look at what this one looks like if we graph this. So I'm going to graph this set of parametric equations. Oops. Yes?
Can I borrow
Kaylee, do you want to be interviewed?
the rugby? Oh, sure.
Wait, what am I doing again? Bailey? That's you. Bailey?
Okay.
All right, so we're going to graph 1 over the square root of x. So, or sorry, square root of t. Square root of t for x, and y was 2t squared. And when I graph that, and notice that the orientation for this one, we went this way. We started here and went up that way. So the orientation from this, for this, is right to left. So my graph looked like that. And we got right to left orientation. So this is an example of a graph where we get the opposite orientation. So to eliminate the parameter, you solve, in general, you solve one of the equations for the parameter and substitute it into the other equation. All right, yes?
So why did we solve for y equals f of x?
The problem asked us to write
Oh.
y equals f of x.
No, it keeps going. But if we were like solving it, we would just put it into, like if you didn't have to solve for anything, you wanted us to graph it.
If you just wanted to graph it, yeah, you can just put it in parametric. All right, sometimes we want to go to the opposite direction as well. And we have a regular equation, and we want to write a set of parametric equations. Now, one reason that we might want to find a set of parametric equations for a curve is, for example, the conic sections we know are not functions. They don't pass the vertical line test. With a set of parametric equations, we can write the conic sections as a pair of parametric equations where each one of the pair is a function. So we can write conic sections as functions. The other reason is when you go further in math, you want to be able to parameterize a curve to do other stuff with it. All right, so we're kind of going the other direction. So for this one, we're going to say we want to find parametric equations for y equals x squared plus 1 with these parameters. For the first one, we're going to say x equals t. Well, that's really easy. If x equals t, then y equals, I'm just going to plug in t for x, y equals t squared plus 1. So that's a nice, easy parameterization. For the second one, let's say for this one, we know that t is x minus 2. Well, I'm just going to solve this for x. X equals t plus 2. And so y equals t plus 2 squared plus 1. Well, this is going to be t squared plus 4t plus 4 plus 1. So y equals t squared plus 4t plus 5. And these two would be my pair of parametric equations. Why would we do it this way? We want our x value shifted 2 units. We want to start when t is 0, we want x to equal 2 for whatever reason. So if we think about this as a projectile motion, when t is 0, we're starting 2 units from the origin. Maybe that's why we do it that way.
2.
Now, if you go further, or when you go further in math, there will be some or many kinds of equations where you will know how to find the set of parametric equations for them. And I want to talk about a couple specific examples, but we're going to go the other direction. And we're going to get a visit from our old friend, Trig. Parametric equations. Yes. No, I try not to watch. So let's say we have the set of parametric equations. X equals 4 cosine theta, and y equals 4 sine theta for 0 less than or equal to theta less than or equal to 2 pi. Any idea what this graph is going to be? No, that's a good guess. Anytime you see a sine and a cosine together, you should think about your Pythagorean identities. We know that cosine squared theta plus sine squared theta equals 1, always. Well, from this equation, cosine theta is x over 4. And from this equation, sine theta is y over 4. So x over 4 squared plus y over 4 squared is cosine squared plus sine squared. That equals 1. X squared over 16 plus y squared over 16 equals 1. Multiply everything by 16. And that is a circle with radius 4. This is the parameterization for a circle with radius 4 with the center at the origin. Hello.
Can I borrow Evan really quickly just for a headshot?
Evan? All right, let's graph this in our calculator. Oops, that's not what I wanted. I wanted my calculator. So x was 4 cosine t. Y was 4 sine t. I'm going to do zoom standard.
Wait, how did you get there?
And it turns out to be an oval because, or an ellipse, because our screen on our calculator is not a square, it's rectangular. So the scale on the x is not the same as the y.
If you press 5,
What's that?
if you press 5,
Zoom 5?
yeah.
Oh, okay. There we go. So that makes the screen a square. So now we have a circle with radius 4. And we count squares. 1, 2, 3, 4.
Wait, can you go through that again? I'm stuck.
Go through what?
How was you making graph?
I just plugged in x equals 4 cosine t, y equals 4 sine t. So based on what we just saw here, what would you guess we get if x equals 4 cosine theta and y equals 5 sine theta? That is going to be an ellipse. The x radius in quotes, is 4 and the y radius is 5. Is it going to be vertical or horizontal? Vertical. The y part is going to be bigger. And the way we'd see that is we get x over 4 is cosine theta. Y over 5 is sine theta. So x squared over 16 plus y squared over 25 equals 1. And if I graph that in my calculator, I'm just going to change this to 5 sine t. And I did zoom 5, zoom square. There's my ellipse. It's not very stretched because this is 5 and this is 4.
This ain't working for me.
If I made this 10 sine t, that would make it a more, there we get a vertical ellipse. And if you noticed when I graphed this, the orientation was counterclockwise. Because, and let's think about it for a second, what's a cosine of 0? 1. What's a cosine of pi over 2? Cosine of pi over 2.
Sine of pi, sine of pi beta.
Is it 1/2?
Yes, the value. Sine, cosine of pi over 2. 0. So x goes from 1 to 0. X goes from 1 to 0. So we go counterclockwise.
Yeah, because the unit circle moves counterclockwise.
Unit circle goes counterclockwise, yes.
Counterclockwise.
Right.
What if this isn't graphical?
What's that?
What if this isn't graphical?
then you're doing something wrong in your graph. If you want to come up when we're done here, I can take a look. All right, our homework. All right, there you go.